आज का हमारा टॉपिक है थर्मोडायनेमिक्स। और थर्मल फिजिक्स। सो व्हाट इज द मीनिंग ऑफ थर्मो? Thermal means heat and dynamics means moving. So this branch of physics deals with the movement of heat energy. So we all know that the heat always flows from positive to negative side. From high temperature to high temperature means heat. Low temperature means cold, or it can be less heated than this one. So if it is 100 degree, then it will be 50 degree. So the heat will transfer from here to here. We can take the example of a hot cup of tea. So the around environment temperature of tea was less than the cup of tea. The tea is hot inside the cup, so the heat flows from the inside of the cup to the outside temperature, reducing the temperature of heat. Okay, so now we will study some laws of thermodynamics. So what is the first law of thermodynamics? It states that energy cannot be created, neither be destroyed. So what is the first law? Law of conservation of energy. Second, then what is the second law of thermodynamics? It states that the energy or heat moves from hotter body to colder body. And as we understood from the example just few minutes ago. And the last, so in the second law you can also add that it also states that entropy of a system always increases. Always increases. So what is entropy, you will ask? So entropy is the measure of disorder or randomness. So till now we have understood the first two laws, which are very simple. So moving on to our third law, what it states? That at absolute zero temperature, entropy becomes zero. So what is the absolute zero temperature? It is the theoretical limit of cold. It cannot be possible. It is only theoretical. So it states that at absolute zero temperature, entropy of a system is 0, but practically it is not possible. But if someone asks you the define the laws, then you have to say this. Okay, now we will move to the important concept of thermodynamics, which is Carnot cycle. Carnot cycle. What is the Carnot cycle? It is the theoretical. What was it? Do you have any idea? It is the theoretical concept of heat energy that it provides the maximum efficiency. But it was theoretical heat engine providing maximum efficiency. So what does efficiency mean here? If we are providing Q1 energy to a system, then it is utilizing the whole energy in the form of work, like converting the heat energy to mechanical in case of our vehicles or the engines in other devices. So they don't really, in the practical way, they don't really are energy efficient. There is a loss of energy. So it means that not practically possible. It is not practically possible because there is always a heat loss. So many people consider it as a benchmark for heat engines. Heat engines or engines. So now we will understand the processes of this engine, which is broken down into 4 parts. So first, it has 4 processes. So first it is isothermal expansion. It means the gas expands isothermally at a high temperature at constant T. So here what happens, if we place a balloon near a hot or we heat it, provide the heat to the balloon, it will expand, but its temperature will not increase or decrease. Why? Because the heat provided by us is directly used in the expansion. So isothermal expansion happens at constant temperature. And in another process we will be covering, I will tell you about it as a what is the second? It is adiabatic expansion. So in last concept we understand the isothermal expansion that happens at constant temperature. But in adiabatic expansion, if we place a balloon, like we remove the heat source as it was in the previous case, so the balloon keeps on expanding using its own energy. That results in the decrease of temperature. I am using this analogy to explain you. So in this case there is a decrease of temperature. Now the third is isothermal compression. So we know the isothermal processes take place at constant T. So in this case we keep this balloon in a cold temperature, because of which it compresses, but at constant T. But in the fourth case, that is adiabatic compression, we remove that balloon from the cold surrounding and it keeps on expanding using its own energy. Sorry, keeps on compressing. So it keeps on compressing using its own energy. So what will happen? So we understood that the isothermal process happens at constant temperature, but in adiabatic there is no heat exchange. So you have to remember. So it is compressing using its own energy that results in the increase of temperature. So these are the four processes of the adiabatic processes of Carnot cycle. Okay. Now we will cover the four important definitions or explanations which comes under thermodynamic potentials. So I will be naming them first. We have total energy, which is represented by U. Then we have enthalpy. Wait a minute. Enthalpy, which is represented by H. Then we have Helmholtz, which is represented by A. And last we have Gibbs free energy, which is represented by G. So I will be explaining all four of these. First, starting with total energy. So if we used analogy to explain this, all four terms, you will never forget them. So consider a kitchen and compare it with thermodynamic system. Then what is the total energy in that case? Total energy is the everything inside that kitchen. It can be ingredients, cooking tools, and chef's energy to cook. This is related to kitchen, but in actual, it considers the all types of energy: heat, work done, chemical energy of a system. So, keeping on with the kitchen's analogy, here in case of total energy, we can use the first thermodynamic law. So, what is total energy? It is the Q minus work done. So, what is Q? So, Q is the heat added. And what is W? W is the work done. Okay. So, in case of kitchen analogy, so we can consider Q as the firewood and work done as chopping, that energy wasted in chopping or something else. So this is the external heat provided and this is the energy used by the system. So if like a the chef of the kitchen receives extra ingredients or get energy from this firewood, then or he spends his energy on chopping, which is considered as work done, then his total energy changes. So we understood that total energy of the system changes. How it changes? If we add some energy or use energy as a work done. So next we have enthalpy. First we will understand in it as the analogy. It is the total cost of cooking. So if like now the thermo who is thermo? Chef. Thermo doesn't just care about what's inside his kitchen, he also needs space. So in this case there is a space he needs to work, also rent he have to pay for the restaurant. So that also adds to the cost of the maintaining. So enthalpy represents that. Enthalpy represents the total energy of the kitchen. Total energy of the kitchen including total energy plus the extra space he needed and he have to pay rent as well, that is PV. So the extra factor added in enthalpy is H is equal to U plus PV. So here U, P and V are the pressure and volume. Next, third component or third potential thermodynamic, we have holds free energy. So what is it as an analogy? It is the chef's effective energy, useful or effective energy of the chef. So it is denoted by F or A. If user A, U is the total energy minus T and S. S is entropy. So here we are calculating the useful energy by subtracting the other factors like entropy. If we understood it as a like analogy, if the things get more chaotic, like in the kitchen there things are more chaotic, in the system means there is more entropy. If this factor is more, then the free energy will be less. If this is 20 and total energy 100, then it will be 80. On the other hand, if our entropy increases to 40, then the Helmholtz energy will be 60. So, increasing the chaoticness in the kitchen, as well as increasing the entropy of a system, decreases the useful effective energy of the system, which is known as Helmholtz free energy. So, last thermodynamic potential is Gibbs free energy. What is it? It's the profit of the shell. So it is denoted by G. So here we have the enthalpy, which covers everything from the total energy to the space and volume required. Now for calculating profit, we have to subtract total energy minus the factors that is reducing the efficiency. In the last concept we understood Ts is that factor. So we will subtract Ts from here. So here what it tells, the Gibbs free energy tells him how much useful energy is left after accounting for both kitchen and maintenance and disorder. So it also plays an important factor in science, as if G is less than 0, G is greater than 0. If G is less than 0 means reaction is spontaneous. That reaction will occur by itself. If G is greater than 0, then we have to do work to make the reaction happen. We have to add the energy. Okay, and in this case the reaction will happen spontaneously or automatically. So we will revise all these four. So U, internal energy, we use for tools, ingredients, everything. and its formula is Q minus W. Then we have enthalpy, which means total cost, including rent, which formula is energy plus PV. Then we have A, Helmholtz energy, what it provides the useful energy. So it subtract U minus TS. Last we have Gibbs free profit. It subtract from the enthalpy minus factor, disorder factor. So we can also cover one more topic here, or we will cover the next topic in the next class. So as it will be too long, then thank you. These all are important things you have to remember. Bye.